Hello, in this video we will be discussing how to find the derivatives of trigonometric functions and how to use the formulas to solve equations. So for example, let's say we have f of x equals sine of x. Well, how would we find f prime of x? Well, we would have to use the limit definition. So as limit of h goes to 0, we would have sine of x plus h minus sine of x over h. Then, to simplify it, we'd first expand this part using the sum and addition formulas. So then we would get sine of x times cosine h plus cosine x sine h minus sine x all over h. Then we can move this over and then distribute out a sine of x. So then we would get sine of x times cosine h minus 1 plus cosine x sine h all over h. Then we can split it up into two fractions, and then cosine of h minus 1 over h is just equal to 0, and sine of h over h is equal to 1. So after simplifying everything, we would end up with cosine of x. So that means that cosine of x is the derivative of sine of x. Now, we could use a similar approach to find the derivative of cosine of x. And we would end up getting cosine of x. The derivative of cosine of x is negative sine of x. After we know these two, we can use the quotient rule to find the derivative of all the other functions. So the formulas would end up looking like this. So on the left side, we have the original function, and on the right side, we have the derivatives. So you should memorize these because they are very important in solving the derivatives of trigonometric functions. So now that we understand how to find the formulas for the derivatives of trigonometric functions, we can do some practice problems. So if we have f of x is equal to x times secant squared of pi x, how would we find f prime of x? Well, first, we can rewrite this as x times secant pi x squared. Now this is easier to see that we have to use the chain rule first. So now f prime of x would equal 2x times secant of pi x times the secant of pi x times tangent of pi x times pi, and then plus 1 times secant squared of pi x. So let's go over what we did. First, we would use the chain rule and the product rule. So on this side, we took the derivative of secant of pi x squared and left x. So it would be 2x times secant of pi x. Then we would have to take the derivative of the inside, which is secant of pi x, and that equals this. And then we have to take the derivative of this, which would just be pi. And then, because we're doing the product rule, we have to take the derivative of x times this. So that would just be 1 times this. To simplify, we can take out a secant squared of pi x. So this is our final answer. Next, we have a different type of problem that is also commonly occurring. So sometimes you will be given an equation and you have to find the points of the horizontal tangent line. So let's say we have y equals cosine of x over 2 plus sine x. So to find the horizontal tangent line, all we have to do is find the derivative and set it to equal to 0, because the horizontal tangent line has a slope of 0. So what that would look like is, for example, like this. So that would be the point where it would have a horizontal tangent line, because the slope is equal to 0. So first we have to take the derivative. So y prime is equal to 2 plus sine x times negative sine x minus cosine squared x all over 2 plus sine x squared. So right here we did the quotient rule using low d high minus high d low over low squared. Now to simplify, we can first distribute out the negative sine x, so we'll get negative 2 sine x minus sine squared x minus cosine squared x over 2 plus sine x squared. Now if you know your trigonometric identities, you would know that this is just equal to negative 1, because you would distribute out a negative 1, and then sine squared x plus cosine squared x would just be 1. So we end up with negative 2 sine x minus 1 over 2 plus sine x squared. And now we can set it equal to 0, which would be the slope at the horizontal tangent line. So if we set this equal to 0, to find 0, we would just set the numerator equal to 0. So we get sine x is equal to negative half. And if we were to graph this, we would find that x equals 11 pi over 6 plus 2 pi n and 7 pi over 6 plus 2 pi n. And this is the x value, so we have to plug it back in to the original equation, which is y equals cosine x over 2 plus sine x, to find the y value. Make sure to plug it back in the original equation, because if you plug it into the derivative, you will get the wrong answer. Also, when you're doing questions like this, don't forget to put plus 2 pi n, or whatever the interval is, because if you forget the interval, then you will also get marked off. This is because trigonometric functions are reoccurring in intervals. So if we plug in the x back into the original value, then we would get as our final answer 11 pi over 6 plus 2 pi n, comma, 1 over root 3, and 7 pi over 6 plus 2 pi n, comma, negative 1 over root 3. So this is our final answer. Okay, now that we've gone over two different types of problems, and the formulas for the trig derivatives, let's go over some key tips. So number 1, remember those 6 formulas. These are very important for solving these problems. Also, remember the trig identities. For example, sine squared x plus cosine squared x equals 1. If you know those, then simplifying will be much easier and quicker. Alright, I hope this video helped in solving trig derivatives. Thanks for watching.